Welcome back to another exciting chemistry lesson. In the previous lesson, we learned about solution and how we mix a solute and a solvent together and we create this aqueous solution of ions surrounded by water molecules. Now in this particular lesson, we are going to learn how to draw the particulate diagrams of showing how the solvation of a salt by water solvent works. So let's look at this. We already know that for any salt, right, we're not talking about sodium chloride. We're talking about any salt basically combined by, you notice this is an alternating negative and positive, negative and positive. So any salt, okay, we're talking about sodium chloride, or we can talk about potassium nitrate, okay? All of those salt, when we put them in water, it's going to get dissolved through the process called solvation. So it breaks it down into 3 steps. The first step is basically the molecules are separate from one another. Well, first of all, we have the solid and the water, okay? So we are talking about the intermolecular force. We're talking about IMF, okay? Intermolecular force. Well, in this case, it's going to be the ionic part, or in this case, we're talking about ionic solid. So they are going to break away the ionic bonding. And this process is going to require energy. Whenever you want to break a bond or to break away the interaction, we require energy. Now, endo is a prefix for enter, okay? So enter, think of the word plus energy. So we require energy. So we absorb the energy, okay? So where's this energy coming from? It's coming from the surrounding. Now, the same thing for the solvent part. In this case, this is for the water. So for this case, the bond breaking part, we are referring to the hydrogen bond. So the hydrogen bond, that's what keeps the molecules together. So this again is an IMF. We are talking about IMFs, intermolecular forces, okay? And the same thing, this requires energy. So as you are absorbing energy to break the bonds in the solvent and in the solute, what is step 3 going to be? Well, step 3 is not going to be breaking bond because the bond's already broken in step 1 and step 2. Step 3 would be forming bonds, so bond making. And this, again, when you forming bond, it is an exothermics. And this is going to release energies, okay? So for this 2, we are talking about absorbs. So energy is absorbed, right here is going to release. So let's draw this out. On your test, you are going to ask to draw out the solvation as in terms of step 3. And the way behind this work is that you see how water molecule has a partial negative and has a partial positive, okay? And this right here is your hydrogen, this right here is your oxygen, and this right here is your hydrogen. And you know, when we look at this, negative attract to positive and positive attract to negative. So if I were to break this in terms of ions, and I want to draw, so on your test, you are going to ask to draw the solvation process where the water molecule interact with the individual ions in the salt. So in this case, we can just use generic term like a plus potassium. It could be any plus ions, okay? So we just use this plus to indicate for any positive charged ions. Now to show the water molecules, we know again, positive attract to negative. So therefore, if I'm looking at this right here, so right there, you can see, think of this like a Mickey Mouse head. This is the partial negative, this is the partial positive, and partial positive of hydrogen. And we're going to do the same thing, right? And there you go. You see how that works? And then you go, you have another water molecule. And notice how the positive charge is surrounded by the negative charges or the negative positive charges of the water molecules. And the same thing for the last one right here. Now, what about when we have a negative ions, okay? So you're going to draw like multiple one of them. I want to draw a negative one right here. So I'm going to draw a big one with the negative charges. So again, opposite attract. So in this case, instead of drawing the water molecule the other way, I want to draw it this way, where you have the Mickey Mouse head are near the negative. So because this is partial positive, and this is negative. And the same thing over here. So in 4 areas, okay, surrounding the salts, ions. And that is all you have to do, okay? If it's asking you to draw step 2 where you break into ions, just draw separate water molecules, just like this. And sometimes they ask you to label the partial charges of water. Again, Oxygen is negative and hydrogen is partial positive. And that is how you draw a particulate diagram to illustrate the process of solvation of any salt by water. Now, just to illustrate this in terms of specific ions, I can just put right here. So let's do this. I have Na plus right here, okay? And I can label that. And again, I'm going to label this a water molecule. Okay, see how easy that is? And then for sodium chloride, in this case, for sodium chloride would be Cl, okay? So Cl minus. And what I'm going to do is, of course, this is going to be the Mickey Mouse head the other way around. You see how that works? So this can be any ions from the ionic compound, and this process will work for any ionic compounds that are being dissolved in water. In addition to knowing how to draw the particulate diagram, it's also understand what happened to the energy, where energy is absorbed in the bond breaking process when we try to separate into ions or break the hydrogen bond. And then the last step is when we form them together. In this case right here, we are going to release energy instead. And as always, if you have any question about your work, take a picture of your work, put in the form, and we will help you from there. And we will see you next time on another exciting chemistry lesson.